Now we're going to take a look at how these exponent rules actually apply in practice. And what you're going to see is we're going to start layering multiple rules in single problems. So the first thing you always want to check when you have a quantity is, do you have any exponents hanging outside? If you don't, the parentheses are just there for clarity, and you are free to rearrange constant by constant and variable next to variable. So I can combine my constants to get 15. When I'm multiplying like bases, that means I'm supposed to add my exponents, and I get 15a squared. There are often more than one way to do these problems. So I could have moved this -2 below first and then subtracted, and you would get the same answer. Now I have these next two problems side by side for a reason, because I want you to notice the placement of the parentheses. Here, the parentheses mean that everything is to the -2 power. I'm going to take care of that first. I'm going to write 5x squared squared. Notice the negative disappears because I moved it all to the denominator. Now I need to distribute that power to a power. And so I have 5 squared times x squared squared. So I have 1 over 25 x squared squared multiply x to the 4th. Now down here, 5y to the -3, that -3 is only on the y. And so 5 stays in the numerator, and y cubed goes to the denominator. And that is the end of that one. Now this last one's very fun. All of this looks very scary inside. As soon as I see the 0 power with the parentheses, the whole thing becomes 1. Does not matter what is inside the parentheses. Now here I have a situation where I have an exponent, so I have to take care of that first. And so I have 3 squared times z to the -4 squared times -5 times z cubed. So I can clean up my constants and get those guys together. So I've got 9 times -5 power to a power. Z to the -4 squared is going to be z to the -8 z cubed. Combine your constants, -45, and I'm going to have z to the -8 plus 3, adding -45 z to the -5. The minus says I need to move it, -45 over z to the 5th. This next one has the multiple rules again. Because these parentheses are around the entire fraction, I can work within the fraction first and then do the power, or I can distribute the power to all 3 parts and then work from there. Notice that that's different than this example we'll get to next, where the parentheses and this power are only on the numerator. So I have to take care of that before I can do any combining to the denominator. I personally like to work inside my parentheses first if I ever can. So dividing means that I'm going to subtract. Now be very careful of your signs. What I end up doing is 2 minus -4. Minus a minus means plus, and so I have 3y to the 6th cubed. Distribute that cubed. I have 3 cubed y to the 6th cubed. So I have 27 y to the 18th. Now, as you get more comfortable, you obviously can do more steps at once, but don't worry about doing too many steps together because that's where you're going to make mistakes. Just do it step by step. So first, I have to distribute this negative. So I've got 3 squared times a squared squared times b to the -3 squared, and that's all over 9a to the -2 b cubed c to the 4th. I'm going to clean up this numerator. I've got 9a to the 4th b to the minus sixth, all over 9a to the minus 2, b cubed, c to the fourth. Now at this point you have a decision to make. You can either handle the negatives and move everything around, or you can subtract by the quotient rule. 9 over 9 is going to cancel. I personally like to subtract, so I have a to the 4 minus minus 2, b to the minus 6 minus 3, and the c stays put. When I work that out, I end up with minus minus 2 is positive 6. Negative 6 minus 3 is negative 9, all over c to the fourth. That negative 9 says, please move me. So I have a to the sixth over b to the ninth, c to the fourth. Again, you could have moved the negatives first, and you would have gotten the same answer. Now, how on earth do we handle these radicals and their fractions? Well, the square root of x squared we know is x, but what does that have to do with the rule? And if you think about doing x to the 2 over 2, which is x to the first power, in the same way that the cube root of x cubed is x, but by our rule, it works the same way. We just don't write the first power. If you see something like the cube root of 16x to the fourth, cube roots are looking for perfect cubes, 3, factors that show up 3 times. So let's use a factor tree, and let's factor 16 and see if we can rewrite it as a group of 3 factors. And if you remember, when we get done with a factor tree, we circle the ends. I have the cube root of, I'm going to regroup this as 2 cubed times 2. And x to the fourth, I'm going to rewrite that as a group of 3 times x. Now I'm kind of using my exponent rules in reverse. I still have 4 2's, 1, 2, 3, 4. I've just grouped them 3 and 1, and I still have 4 x's. I grouped them as 3 and 1. Why I did that, it's kind of like the old days in division when you got to do remainder 5 when you were done. I'm going to leave a remainder, whatever doesn't have a perfect cube, under my radical, and that's going to be my exact answer. So 2 cubed cube root is 2. That one comes out front. This 2 can't do anything, so I'm going to leave that under the radical. X cubed cube root is just x, and x, the cube root of x, can't be simplified, so that stays under my radical. So my exact answer is 2x times the cube root of 2x. Now let's look at a little bit more difficult problem. This one has a power and a root in it. I'm going to deal with the root first because that usually will make my numbers smaller. So I'm going to go looking for perfect cubes. So I know that 3 goes into 27, and lo and behold, that ends up being a perfect cube. Now, if I make a group of x3 out of 6, then that means I have another group of x cubed. I still only have 6 factors. So if I rewrite this, I've got the cube root of 3 cubed, x cubed, x cubed, the entire thing squared. I haven't changed my numerical value, but I've just rewritten it in terms of cubes. So the cube root of 3 cubed is 3. The cube root of x cubed is x, and the cube root of x cubed is x. And all of that is squared. So this is 3x squared squared. Now distribute that outside, and I have 3 squared x squared squared, and I have 9x to the fourth. This idea of simplifying radicals will be covered more in the next lesson, so this is a nice preview transition to that.